Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Snack Latin Arrows, and it's by Senny K. And here are the rules. We have Latin square rules, where we need to place the digits 1 through 5 exactly once in each row and column. We have arrows, where digits along an arrow sum to the number in the attached circle. So if this were, say, 2 and 2, this would have to be 4, because the sum of 2 and 2 add up to 4. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the one that's the most restricting is this arrow here, obviously. This could be the sum of 1 4 times, or it's 1 3 times, and then a 2, because the most you can have as a digit in this grid is 5. So this is either 4 or 5, and the rest of these digits must be 1 or 2. We know there's at least 3 ones here. What else do we know? We know these digits have to be the sum of 1 through 4, obviously. So these could be 2 through 5 here. Can this ever be 1 and 1? No. If this is 1 and 1, that would force this to be 2 and 2. This would then add up to, at minimum, 1, 1, 2, 2, which is 6. So it cannot actually be 2 there. Same with this, right? If this is, well, yeah, if this is 1 and 1, that would force this to be 2 and 2. So you have the same problem here. So this is 3, 4, 5. If this were 1, that would force this to be 2 and that to be 2, which would again have the same problem. So this cannot be 1, which means this can't be 4 here because 4 and 2 add up to 6. We have the same problem here, right? If this is 1, that forces this to be 2 and 2. So therefore, this can't be 1 because we could have this add up to 6 at minimum. So then this can't be 4 here. Hmm. What else do we have? We can't have 1 here or here. Because if we had a 1 here or here, the problem is they would see two cells on the arrow and would force both of them to become 2. So I think that's the same for anything in this square, essentially, that's not on the arrow, right? If we try to have a 1 in any of them, right? If you have 1 here, any of these spots, they would eliminate 1s from 2 cells on the arrow, which would force it 2, 2, 1, 1 at minimum. So these cannot be 1, which means what is 1 in column 3? It has to be here. So this is definitely a 1. We have 1 here or 1 here, 1 here or 1 here. You could have 2 in any of those places because that's fine. 2 has to be, in fact, one of these 2 in column 3. Because 2 is one of these 2, so we know we have 2 either here or 2 there. What else do we have? If this is 4, these all become 1. That's not possible. So if we have a 4 here, all of these become 1. And then the problem is, where is the 1 supposed to be in row 1 or column 1? These ones would eliminate 1s as possibilities here and here. And would have to be here, but obviously it cannot be there, because it has to be the sum of these digits on the arrow. Therefore, this has to be 5, right? Because if we try to make this 4, that forces 1s all the way here. That eliminates 1 here and 1 here, so 1 has to be there, but we already have a 4 there. So this must be 5. And we have to have a 2 in one of these 3 cells. Well, this can no longer be 5 here. So this is 3 or 4. What else do we have? Remaining digits in row 1 have to be 1 through 4. 1 through 4. Remaining digits in column 1 are 1 through 4. So we know in row 2, 5 has to be one of these digits. In column 2, 5 has to be one of those 2 digits. This can't be 4 here anymore, right? This can't be 3, because it adds up to 3 or 4. So we have a 1, 2, 1, 2 pair in column 4, right? This could be, since this can't be 1, this has to be at most 2 and 2 to add up to 4. This is only 1 to 3, so the remaining digits in column 4 can't be 1 or 2 because of the 1, 2 pair in the column. So this has to be 3 through 5. So we know in row 5, the 5 can only be one of these 2 digits, which means we have a guaranteed 5 in row 2 in columns 3 and 4. We have a guaranteed 5 in columns 3 and 4 in row 5, which eliminates 5 in the rest of the column, or in the rest of those columns, because we have a guaranteed 5 in one of them. This can't... Oh, we have 2 being one of those 2. Okay. So this has to be 2 through 5 here. This is 2 through 4 here, because again, the 5 cannot be anywhere else in columns 3 and 4. And we have a similar situation here, but we've already, well, we've shown that this has to be specifically 3 or 4, and no 5 there. Okay. So, what digits are these? This will make blue, and I guess we'll make this orange. Does that help any? Not particularly. If this is 2 and this is 2, the problem with that is that would force this to be 1. The 2 here would force both of these to be 1, and then it would have to add up to 4, and we'd have the same problem here of where can the 1 be. So this cannot actually be 2 and 2. That means this can't be 2 and 2. It cannot be 2 and 3. This can't be 2. Therefore, this is 1, which forces this to be 2, which means the rest of these are 1 to add up to 5. That means this cannot be 2 here. Where is the 2 remaining in column 3? It has to be here. That's 2, which means this can't be 2. That's 3, which means this can't be 1, 2, or 3. It's 4, which makes this a 5, so this can't be 5 here, so that's 5 here. 3 plus 1 is equal to 4, so that's 4, which makes this 3. There's no 5 here because of 5 in the column. No 4 here. This can't be 3 or 2, so this is a 1. To add up to 5, it must be 1 and 4, so this must be 3 here, which makes this 4. That leaves this digit as a 2, which makes this a 3. No 1, 3, 4, or 5 here, so this is 2, which makes that 3. That means the remaining 2 has to be here, the remaining, because we have 4 2s. We all have all the 1s now. We have all the 3s. That leaves this as a 5, this as a 5, and this as a 4. Okay. I hope you have enjoyed the puzzle, and if so, I would appreciate. Okay, yeah, so this is Senny K's typical thing. Interesting. That was interesting logic there. Obviously, I haven't done very many 5x5 Latin squares, so, but it was interesting how those interacted to restrict things. Yeah, definitely very easy because I didn't have any intuitions about this, and I was just basically going along, just trying to figure out what the possibilities were, and was able to pretty easily deduce what the possibilities were, but mainly it was just basically by just trying things out, right? What happens if you have 4 here as 1, 1, 1, 1? Well, then you have a problem. What happens if you try to have 2 and 2 here? You have a problem. And that's actually a lot of the times what happens with Sudoku solving. It's basically just trying things out and then basically going, oh, this leads to a contradiction. So, yeah. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.